Good morning, students. Today I'll discuss with you derivation of equation of motion by graphical method. In this, we are going to find the relationship between the initial velocity, final velocity, acceleration, time and the distance covered by uniformly accelerated motion. So, students, see here. I have shown you speed time graph or velocity time graph. How will you make this? So very simply, you draw with ruler and pencil x-axis. You draw y-axis straight line. Now, this represents your time as I have shown you, that is x-axis. Y-axis represent your velocity. For this case, let the body is having some initial velocity u. So, I have shown from here. It has some initial velocity u which is starting from A and finally it's reached at certain position B. So, I have shown A, B. See here, a body having some initial velocity u, moving after certain time t, it reached at a final velocity, that is point position B. So you see here, I have shown you initial speed we are denoting by u, acceleration A, time t and final velocity. It attains final velocity v. It covers this distance. From this graph, what you have got? O, starting from O, A, B, C. Only we have AB is the moment. To find the relationship between this slope and x and y axis, I have dropped one perpendicular on the time axis, that is BC. This I have drawn one perpendicular. Again, to find the relationship, I have drawn another perpendicular, that is AD on speed axis. So, the time axis, this perpendicular, speed axis, this perpendicular is being drawn to find the relationship of AB with x-axis and y-axis, that is time axis and velocity axis. You see here, OA is parallel to CD. Both these are parallel. OE, this is parallel to BC. And this is our velocity. So, this also represents velocity. OC is parallel to AD. And this is time axis. So, these are the description of graph. Let us start deriving one by one. How we will do it? Say, first equation of motion, you are knowing V is equal to U plus AT. We are having A, B, that is acceleration. So, acceleration we know that what? BD by CD. That is, we have done BD from this triangle and AD. This is the acceleration slope triangle ABD. I have written, you see here, BD is BC minus CD. BD is BC minus CD, and so this BC is V and CD is U and AD is parallel to OC, so that is time t. So acceleration slope is AB. I have written V minus U by t as we have got it. So cross multiplied AT, V minus U. Finally we have got first equation of motion, that V is equal to U plus AT. This relation shows velocity time relation. Velocity and time. Then you think that why not acceleration? Acceleration is change in velocity, so we are not considering it. This is finally shows velocity time relation. So this is the first equation. Come for second equation of motion, that is S is equal to ut plus half at square. Again, from the figure you see, body is starting from initial position A and covers B. So what figure we have got? O, A, B, C. Previous we have discussed distance covered is area under the graph. So this total area under this graph, that is we have started from initial position to final position. Always I am saying you take care of initial position and final position. So area under the graph OABC. This is your trapezium. So area of trapezium OABC. Under OABC, we are getting two shapes. One is triangle and another is rectangle. So let us discuss area of rectangle OACD and area of triangle ABD. So this sum total is the total distance covered. So area of rectangle, length into breadth, and length is OA into OC. Just you see here OC length and OA breadth. So OC into OA. And area of triangle, half base into altitude. We are having base AD, we are having altitude BD. So half AD into BD. We know by substituting the values, OA represent U, OC represent T, I have indicated over here, plus half AD. AD is what? Parallel to OC, that is time axis T. So I have written over T, and BD, just I have found BC minus CD, so we have got V minus U. From first equation of motion, put the value of V. V is equal to U plus AT. So I have written over here U plus AT minus U. U and U cancelled, plus minus AT we are having. So remove the bracket, you will get UT plus half AT into T, AT square. So we have got second equation of motion, S is equal to UT plus half AT square, and this gives us what? Position time relation. This is your time and distance is nothing but change in position. So this gives position time relation. And finally come to third equation of motion. Again you have understood the graph. Third equation of motion is V square minus U square is equal to 2AS. Again let us start from S, that is distance covered. Distance covered is area of trapezium OABC. You know the area, half sum of the parallel side into distance between the two parallel sides, that is height between them. So half sum of the parallel side OA and BC. So OA plus BC, and distance between them is AD, or you can say OC. So I have written over here OC. Substituting the values of OA, BC, OC, everything as I have denoted over here. So what we have got? Half. OA is U, BC is V, and OC is type T. Now, in third equation of motion, we don't need time T. So, from first equation of motion, we replace the time T. V is equal to U plus AT. So, T is equal to V minus U by A. Substituting in place of T, V minus U by A. So, 2A and S cross multiplied, we have got 2AS. U plus V plus U into V minus U. We know from the identities A plus B into A minus B is equal to A square minus B square. So we have got 2AS is equal to V square minus U square. So this is the third equation of motion. What this relation gives? This gives position, that is distance, and velocity. Position velocity relation. Okay.